past few weeks, we've been bombarded by these images that were created by the AI. They start from a copy, a text, and transform visually, so they become more and more realistic. And this video that you are watching is devoted to this event. I told the AI to generate a video, and this is it. And this is how we work in our lab. We are researching and contaminating the desire of being artists with technology. AI is now devoting its attention to the Atlas of Digital Art, and is now creating something that is quite cartoonist, because this is something that I asked the AI to do. So the most interesting concept from my point of view is the constant comparison with the world of our knowledge. Let me therefore show you this map, which is a sort of a point of reference. This is the NeurIPS map, and every dot refers a paper, and the paper can be close only if they're very similar, and it's calculated by an algorithm and supervised. The color depends from the year of publication, and these squares and rectangles allow me to indicate all the sub-areas of the AI. So a temporal visualization allows me to set up this phenomenon since its birth 37 years ago. And so artists on AI work start from neuroscience scientist background. I steer a team within a bigger team that works in neurosciences, and as you can see, bottom up in green, this map is created. Then you can see contaminations in different areas, and we end up in new areas that were started in 2012 in yellow. Now, from my point of view, and I have a more visual aspect of this phenomenon, as I'm interested in these areas, you see adversarial and vision. So I would like you to have an immersion experiment that encloses thousands of papers. So if we zoom into the map, we can see all of the neural networks that, for those who work in art and AI, have visual does. So autoregressive models, generative adversarial networks, and so the autoencoder was one of the most important things, and now we are also focusing on denoising diffusion models. So what is the experiment that I would like to do with you today, artists and AI? So with generative AI, we also work in neural rendering. So as an artist, I have this role of reading all of these papers and also participating in the tests. 2 years ago, for example, and then in 2018 at NeurIPS, we spoke and dealt with the 3D topology transformation, and essentially the idea of using generative system offered a new aesthetics to sculptures. Here you can see the David by Michelangelo transformed into a network. And this really recalls to mind some other important past authors, but with a new technology, of course. And the aesthetics cannot be developed if not through the neural network. So with my visualization of networks, these are the nodes that come up. And this is the only model that can be obtained, and this shows what AI can do and that in the past we could not perform. This is an overview of the most widespread architectures that people with my experience immediately recognize. They're very different. I do not have a lot of time, so I will not represent them all, and these are the GAN ideas. GANs have a problem. The training data has to be high quality without clusters. And you see, if there are clusters, some areas will be carried out very well in terms of latent space, but other areas will be inaccurate. So they're an extremely powerful architecture, and you have to be very careful when you do the training of these models, because they're adversarial. They fight between each other to carry out the best training data. So if you have a lot of resources, then you use these technologies. So a collection of dogs. Let's add a random vector z1 and we generate a dog. No maths in my slide. I just want to invite you to enter visually and emotionally in this new experience. Then Z2 makes me create another dog. So the interconnection between Z1 and Z2, just manipulating the input random noise, I can play with the system, create an aesthetic that many of you have already seen in many shows and exhibitions. This is the shifting aesthetic, so moving from one vision to another vision. So now, with this experiment that I will create with you, a video, let me show you the fusion model architecture. And I'm talking about this because one of the last projects of my lab is diffusion models. In the creation of images and pictures that belong to this system is very wide-ranging, very cost-effective, no environmental impact, and so we have a wide range of hypotheses. So very rapidly we can achieve this result. It's not as complex as a GAN, and this is what we achieve. The training data is destroyed thanks to the Gaussian noise. So step by step, the system reconverts it from a random noise. This system creates an image, a picture. So as we did earlier, the random noise 1 and 2, and we add, by destroying the random pattern, because we are building up the picture, the image, and starting from the same sentence, there is a component of language models in the system, and we see these images of a robo which is picking flowers, so a message of peace. And so we move from Z1 to Z2, and this is what we do with our discipline. The research, of course, goes beyond. What can we do more? Well, we can add camera movements, camera angles, and this is what we're doing now. So a diffusion that can create video, not this type of quality that is very low, but we can create a pan, a zoom, and many different camera movements in the video. So short variations in the way in which we change the model, and we achieve different visions and images. So the attention to the slightest detail is very, very high. So this is the dilemma now. What should we use, GAN or diffusion? It depends on the project that we want to develop, because they have different characteristics. Diffusion has this ethical value in the backdrop, so very important. Now let me go back to our project in 2021, Strolling Cities, my lab, Mind Earth, Polytechnic of Milan, and the Watson Lab. And let's look at what happened. Data, a powerful data collection of millions of pictures collected in many Italian cities in the north and the south, with this video camera that can be carried on the shoulders and takes pictures at the same height, at the same position. So a high quality of collection of data. Many students of the Politecnico toured the Italian cities and asked questions questions to the citizens. What do you feel when looking at these images? And we can really cage into the images in front of the model. So we can reproduce the city that evokes emotions. So in this case, the sense of safe and unsafe. But we really collected many, many different emotions. And then by adding and more sophisticated processing, we also identified the basic parameters that allow the model to interpret which part of the image conveys a safe or unsafe emotion. Another example, the system highlights what in the image makes you feel safe or unsafe and assess those images. Then, by adding more sophisticated language models, we can also achieve high quality of pictures, and the system can see whether a place is romantic or depressing in Venice. So the system not only learns to respond as a mirror to what we say and we show, but also evoke emotions that we would like these people to feel. And then traditionally, we also like to offer a perfect high quality of these pictures, highly realistic. I ask, I want a red brick or yellow brick road. And so questions and statements that are more complex. This pink house with green windows close to a river. I changed the sentence. And this system works in real time. And so it would really be nice for you to try it out in the future. Now, by closing, I would like to show you the result of the experiment I've carried out. What happens if I ask someone to play Michele Di Mauro in Federica Fracassi, and read poetry by Giuseppe Conte, Arriving in Como. The first one is made with the gun system and the second one with the diffusion system. And let's try and understand the differences. Even the format is different. It could be different.
È delle città come dei sogni.
Oh, it's got
Tutto l'immaginabile può essere sognato. Ma anche il sogno più inatteso è un rebus che nasconde un desiderio, oppure il suo rovescio, una paura.
Como. Arrivo a Como dal mare, dopo aver attraversato orizzontali pianure, risaie, pioppeti, e Como con il suo lago, le sue alture, il suo biancore, mi ridà il senso del movimento continuo e della verticalità aerea. Così mi ritrovo dalle mie parti. Il lago lo direi incastonato tra case e vette, come una spilla di diamante. Se non fosse che l'acqua sciaborda e di notte sembra volersi annettere le strade. Sembra voler diventare un mare in sogno.
È delle città come dei sogni. Tutto l'immaginabile può essere sognato. Ma anche il sogno più inatteso è un rebus che nasconde un desiderio, oppure il suo rovescio, una paura.
Como. Arrivo a Como dal mare, dopo aver attraversato orizzontali pianure, risaie, pioppeti, e Como con il suo lago, le sue alture, il suo biancore, mi ridà il senso del movimento continuo e della verticalità aerea. Così mi ritrovo dalle mie parti. Il lago lo direi incastonato tra case e vette, come una spilla di diamante. Se non fosse che l'acqua sciaborda e di notte sembra volersi annettere le strade. Sembra voler diventare un mare in sogno.
Abbiamo visto
So we have seen these two experiments. Thank you. And thank you to Luca. He's here with me and we work together. So let me underpin that there are limits in the training data to avoid a burning forest. Of course, we collected all the different images and the students could only collect certain images and we could not have the idea of the diamonds with a gun, whilst the diffusion, it could offer a more complex visual language. So thank you very much for your attention.